so what are we doing? So our universe is going to have a bunch of things, right? The universe first is going to have a set of objects. And so whenever you say for all or exist, it's the same set of objects, right? So that's going to be assumed unless somebody tells you otherwise, right? And it's going to have some relation. No, actually, it's not a relation because it's on one thing. A relation is two objects, the relation between them. This is called a predicate. For every y, it tells you whether alpha is true or not, right? So it returns true or false for each object, right? Alpha turns, right, had an alpha and a beta. Alpha would turn true, false for every object, and beta could give you a different true and false for every object, right? So we have that, and we have a function that maps objects to objects, right? So x is an object, f of x is an object. They're both terms, right? Does that make sense? All right. And those are our sentences. You can't see them, but they're going to go up on the top, right? All right. So we parse it. Everybody buy this parse tree, right? And the colors. Do you see the colors of the game? Right? Should we go over that again, or people got to cut the game down, right? So we're going to guess it's valid. So we're going to get an arbitrary universe. And, oh, I guess my slides are in a funny order, right? I was banging out slides on the weekend, right? So, yeah, today's Monday. That was the weekend. I lose track. You know, the problem with my life is I'm home every other day. I lose track of what weekend is. Anyway, right, so let's get some intuition here, right? This says, it says alpha is always true, right? So if alpha is always true, then if you give me an x and I map it over to something, then it's what is f of x? F of x is just some object, right? If x is an object, f of x is an object, it's an object from the same universe. And since alpha is true for every object in the universe, it's true for my f, right? Does that make sense? Right? People good with that? No? Say something. Good. We got at least one good, right? This says it's true for every object. This says you give me an arbitrary x, I don't know what it maps to, right? But I do know it maps to an object in my universe. And I know that alpha is true for every object in my universe. So I know alpha is true for my object, right? Everybody buy that? Right? And what, let's just sort of, this is my term question again, right? What's the statement here? She's assuring me that if you give me Sam, I'll assure you that alpha is true for Sam, right? You give me an arbitrary term, which is an arbitrary object, right? And it's true for that arbitrary term, right? So now I'm going to give you f of x. Why do I give you f of x? Because that's what I want to know about, and it's an arbitrary term, right? So she assures you it's true for that arbitrary term, right? Does that make sense? All right, now we're going to do the game, right? We assume the left side, right? The advantage of not tracing out that weird tree is it gives me space on the screen for putting proof by picture, right? So she's assuring you of this. And what is that saying? That's saying all the alpha is true everywhere, right? Then what do I have to prove? I have to prove this, right? Let's have to prove this. How do I prove it? Oh, here I didn't move that. the blue, the purple up. I was going to move them all up here. But here he says, I got you an arbitrary X, right? So what do I do? Oops, let's not go too fast. What do I have to prove? I have to prove for my arbitrary F this thing, right? Everybody got it? I'm given an X. I have to prove that alpha is true for F of X. Now, what's fun about this example, right? The dotted line before was adversary gives me a value and I give it to the oracle, right? But we're not doing that here, right? The oracle is ready to take a value. I have a value and the oracle is ready to take a value, but I don't just hand it to her, right? I take my value of X. There's some function F that I don't know, but I apply F to my X. It gives me some Y. I hand that Y to my oracle, right? Does that make sense? Right? And now she says, well, because it's true, F is true for every Y, it's true for this weird thing that you gave me, right? And I say, great, and we're done the game, right? Does that make sense? Right? So here, somehow I prove the Y statement, and in just one line, we got the, in some way, if it's true for every Y, I can replace the Y with an arbitrary term, right? So I'm replacing it with this. If it's true for every Y, it's true for this object, right? Now, X is a free variable, right? So it's true for this free variable, hence we can add the Forall, right? Does that make sense? Right? Oh, here I'm doing syntax, right? Syntax tells you whether strings are the correct format, right? And the formal proof that should be here is just done purely syntactically, right? So that's what George wants. He wants to prove completely symbol manipulation without any intuition, right? And without meaning. So here's the substring. It's technically a term. Now I hadn't ever defined term before because we hadn't. Now I should go back into their parsing and our parsing section and define what a term is, right? So that's a term. And in fact, that's a definition of a term in the slides and I cut it out. All right, so anyway, it returns an object and hence the Forall can replace it. Right? Does that make sense? Just purely syntactically. All right, so here's another one, right? And I guess I had the intuition it was wrong, right? Just saying, suppose for every X, alpha is true for what I map it true, right? So it says what the F's are true. The range where the F's are hitting are true. But does that tell me it's true for all of them? No, I don't think so, right? So we want that to be false. So we're gonna we just make it false for somebody, right? I made it false for Marilyn Monroe, right? Now I need some function. So we're just doing we're just doing example here. I blank out an example. You know, you're on your test, you're on the side paper, and you're trying to see, can we make this false? So you come up with this false, you make one of these false, right? And then you're trying to make this, what are we trying to make this? True, right? We want to make everybody hit true. So I don't know, I wrote down an arbitrary function. And why? Because I didn't know what to do, so I wrote one down. And so then I say, well, do we get what we want? Well, Marilyn Monroe's false, right? right? I don't know. Let's see. Say I take F. I want to show this. All right, give me an arbitrary guy here, and I like Marilyn Monroe because she's false, right? But Marilyn Monroe, Marilyn Monroe maps over to Marilyn Monroe, and Marilyn Monroe is false, and so, that's false, and hence we got false up there, right? Everybody see, I just hacked somewhere, and I got false on the left-hand side. Is that good? Are we happy with false on the left-hand side? No, right? Because we wanted that to prove this thing is false. We wanted false on the left-hand side, right? Everybody following, right? So I created a universe, hoping to get a universe in which my statement was false, but then my statement was true, right? So what does that mean? Well, it either means we came up with one universe in which it was true. Does that prove anything to us? No, it doesn't prove it's not valid. It doesn't prove it is valid, right? So we try again, right? Here, last time I got, somehow I have better insight now, right? Now I say, look at, and's not hit, right? So we can make and false, right? Because this is only saying the guys that are hit are true. We can make and false, all right? So is alpha true for every object? No, it's not true for and, right? But now, can we prove this statement? All right? So I don't know why I have Marilyn Monroe here. You give me an arbitrary x, all right? That's kind of all the x's, right? You give me some x. We're doing them in parallel, right? What do I do with those x's? I map them over to y's, right? Where do they go? They go to everybody except Ann, right? And look at everybody but Ann is true, right? So this thing is true, right? People buy this? Are you guys getting this better this time? Right? Right? All right, so now we think, hey, this is cool. What this is saying is that it fell apart because F didn't hit everybody, right? So let's add a new constraint that F hits everybody, all right? So, right, so let's come, I don't know what all this, here's our intuition, right? Suppose we have a function that hits everybody, right? Then we have to prove every y. Well, let y be arbitrary, right? Here we're just kind of coming up with our intuition, right? So we need to prove alpha is true for every y, right? So you give me an arbitrary y, say n, and I have to prove, what do I have to prove? I have to prove alpha of y, right? So, well, y is, we know that everybody is hit, right? So y is hit by somebody. Who's it hit by? It's hit by Beth, right? Now, what does this say? This says for every x. Who do I give for x? Do I give Ann for x? No, who do I give for x? Come on, you should all be jumping here, guys. You give Beth, right? I give, right? Let's see here. I give, right? I give Beth, and it becomes true, right? And we did it for all. Everybody following this? How many people feel they're kind of getting it, but they're shy to say anything? How many people still feel like, I don't know what's going on? Anybody? All right, well, hopefully. All right, so what do we got here? This is grabbed from Wikipedia. All right, and it's talking about surjection or onto or various things, right? So here, what do we need? We need the statement, you give me any guy being hit, any V, and there's some U that's hitting you, right? You give me a Y, I give you an X that's hitting you, right? And I change it to UV, I don't know, just to make the letters different. Everybody good? All right, so now this is just back to our parse tree, right? This, we're parsing that, which parses this way. He has an oracle, we're parsing this way. And this, how does it parse? It parses like this. Well, if the oracle is assuring you of the and, then she's assuring you of both, right? Everybody kind of buy these parsings? So we have two oracles in both cases. How do these two statements compare? Right? In the left one, I have an oracle that assures me, the first oracle assures me of A, the second oracle assures me of B, and I have to prove C. That's the game, right? What about this one? In this game, I have an oracle assure me of A, and I have an oracle assures me of B, and I have to prove C, right? Is it the same game? It's the same game. Are these two statements different? No, they're the same. In fact, if we went back to our and and or slides in the purple table, you could prove that these two statements were the same, right? All right. So, and I'm giving the oracles different names simply so that when I say an oracle gives it to me, we know which oracle we're talking, right? They're playing different games on their statements, right? Everybody good? So this is the statement that we wanted to prove before, that if everybody you hit is true, then everybody is true, right? And that wasn't true, right? But we wanted to say, let's pretend that we know that F, let's require that F is surjective, that for everything to be hit, there's something hitting it, right? And what we want to prove is that if F, what does this say? If F is surjective, then we get what we were trying to prove before, right? People follow that? All right, so now we build our parse tree. So what are we saying? We're assured of this, and I built the assuring game, right? And we need to prove this. And I didn't prove the game yet because we still need to parse it, right? This parses, we're assured this, we have to prove this, right? Everybody see that? So what's the game? We have two oracles, and we have to prove something, right? Same games. Everybody good? All right, so we're going to prove it's valid, so we're going to assume an arbitrary universe. And I need to prove, right? I need to prove that this side gives me that side, right? How do I do it? Well, I have an oracle assure me of the left-hand side that every V has a U, right? And then I have to prove this whole right-hand side, right? How do I prove the right-hand side? Well, it's an implies, right? So I have an oracle assure me of the left-hand side. What's she assuring me of? For every X, F of X is true, right? Everybody getting that? Now I have two oracles, right? And what is my goal? My goal is to prove give me an arbitrary y. I need to prove that arbitrary y is true. Right? Everybody seeing how we're setting up the game? All right, so let's play the game, right? Here, where are we? We're starting up here. Oops, don't go so far. We're up here saying, I'm playing my game, so the adversary gives me an arbitrary y, right? There's my arbitrary y. What do I need to prove? My goal is to prove that that y is true, right? That's our goal. Everybody follow what we're doing? All right, so we ran out of paper, so we start over, right? Here, those are our two oracles, and what are we trying to assure? We're trying to prove, that's why it's blue, we're trying to prove that my adversary's y is true, right? Everybody got the three statements? All right, now how do I do that? Well, I got my two oracles, right? And I got to just, now it's a little harder because I have to decide which oracle to prove things about. And, right, this oracle will tell me thing about F, but I don't know about F yet. So I'm going to go over to this oracle tells me something about F, right? So I go over to this oracle. She says, you can give me any object V you want, right? And what do I say? Hey, I have a red Y. I'm going to give you my red Y, right? Everybody got that? I give my oracle the red Y. What does she do? She says, well, because it's true for every V, it's true for your Y, right? So she's assuring me this statement here. It's the same statement where I plugged in the Y, right? She's assuring me of that. And so now she's ready to give me some object, right? So she gives me, here it is, it's kind of hidden under here, but she gives me a U sub exists, right? It's a U that she's assuring me exists, right? And what do I know about it? I know that F is true for it, right? Does that make sense? So, oh, no. She says F goes to it, right? So what do we do again? She's assuring us that everybody over here is hit by somebody. And she's willing to tell you who. So I say, I need to know about Y. She says, you will hit your Y. Right? Everybody get that? She's a very useful oracle. She assures me that somebody's hitting my Y. Right? And we know we need that because the thing was false otherwise. Yeah? Yeah. So whenever we're going to always assume all our set, the universe provides one set, and every set will be the same unless we tell you otherwise. All right? And so the whole key is that these sets are the same. Now, in fact, all this would be true if there was an X set and a Y set, but certainly the V's are the Y's and the U's are the X's. And why did I change their names so that it made it, in fact, I did it so to make it a little harder, right? To see, so that you could see what we're actually doing, right? She's taking a V and giving me a U. So I give her my Y, and she gives me a U, right? She could have said, I'm giving you an X, right? Everybody got that? All right, so now we know this, right? Right? The adversary gave me an arbitrary Y, and I know something about the Y. I know a U such that F of U is my Y, right? So now I go to my second oracle. My second oracle says, you give me any X, and I'll assure you that F of X is true under alpha, right? So what do I give her? What do I give this oracle? I give her U, right? I give Oracle 2 the U. And what does she do? She says, well, something is true for every X, so it's true for your U. In particular, we know that this is true, right? Everybody got that? And I say, fantastic. If F of, what do I know? I know two things. I know that F of U is Y, and I know that alpha is true for F of U, so hence I can conclude that alpha is true for Y, right? There was another little rule we needed about our logic, right? That if these two objects are the same, and alpha is true for one of the objects, then alpha is true for the other objects, because the two objects are the same, right? And that's the proof, right? Everybody get it? All right, so this proof, when I went over it last weekend, I was like, oh Lord, this proof, they're never going to get this proof. All right, so I skipped all formal proofs, right? But then I was like, can I figure out how to explain this proof, right? At some point, we're going to have to understand this proof, right? And I said, well, I was reworking the slides to be step by step with, this is what I know, go forwards. This is what I need, go backwards. And I worked it out that way, and that way it's a good proof, all right? So let's just do it. I need to prove left side gives me right side, and we're going to separate my proof into things that I know are true and things that I want to prove are true, right? And how do I prove the things I need? It's from the things that I have, all right? So here, I need to prove left side, right side. How do you prove left side, right side? You should all be shouting out deduction, right? So all I do is I write down deduction, right? What's the deduction? Well, my goal is to prove left side, right side. What's the left side? I'm assuring of this left side, right? What's my right side? Oops, it's another implies, right? Everybody see that? That's just banging out deduction, right? All right, so, well, again, I have a choice. I can start with what I have and move forward, or start with what I need and move backwards, right? So it's a bit of a flip of the coin, but part of my goal is to follow the proof that we did before. And, right, we're building up our game, right? So our game says, oh, now how do I, right? So I guess I tend to focus on what I need and not my oracle, right? Because the oracle can do lots and lots of things, but I don't know what I need her to do. I don't know what I need to give her until I know what is my goal, right? In fact, if I never use this oracle, I don't care, right? My goal is to prove this thing, right? So I'm going to focus on what do I need to prove. I need to prove the left side equals the right side. How do I do that? Deduction, right? We bang in deduction, right? So here, what we got here, my goal is to prove left side, right side. I assume the left side, it gives me the right side, right? And one thing you'll note here is here, I don't know how to get this statement, right? So I didn't write here how I got it, right? But now I wrote how I got it. I got it from the conclusion of this deduction, right? But I still need this line. I don't know how to get this line, right? But basically, what do I have? I know this is true. I know this is true. I have to prove that this is true, right? That's the game we were playing before, right? Everybody got that? All right. All right, so now let's keep working backwards, right? Right, because I don't know how to use this oracle. I don't know how to use this oracle. We work backwards. I need to prove a Forall Y. So what would the rule before be? Well, I got to add that y, that Forall. So my line before would be, suppose I can prove alpha y is true, where y is a free variable, right? Then my next line would be add the y, right? So what are we saying here? We're saying, how do I prove for all y? Well, I let y be a free variable given to me by my adversary, right? And I'm going to prove prove it's true for that y, and then I'm done, right? So we're just doing the game that Jeff proposes, right? Everybody good? Okay, we work backwards again. How do I prove this? How do I prove that y is an arbitrary y? I need to prove alpha for an arbitrary y. So, well, I just kind of think about my oracles. Well, this oracle doesn't tell me anything about y at all, about alpha at all, right? It's not going to tell me that alpha is true. It doesn't talk about alpha, right? What does this oracle do? Well, it talks about y's, but it only talks about f of objects, right? So I need to know something about f of objects. So here's a bit of a leap, right? Here I'm going to add in a bunch of things, right? These are all things that I need. How am I going to get this line? Well, suppose that I know that alpha is true for f of some object, right? Suppose I knew that. I don't know how I'm going to prove it, but suppose I could prove that, right? Suppose I could also prove that f of x, that some object, is y, right? Then I'd be done. Let me say it again. Let's go the other direction. I need to prove that alpha is y. What happens if I knew that y was f of x for some x, right? And I knew that alpha is true for that f of x. Everybody see I would be done, right? And what's the rule I laid down here? Well, we haven't done all these rules, but it's a reasonable rule, right? It says, suppose I have two terms, right? Two objects. And I know that those objects are the same object, right? In this case, is I know that f of x is the same object as y, right? And suppose now, what does that tell me? That tells me that alpha is true for the one object if and only if it's true for the other object, right? Does that make sense? It's a reasonable rule here that when we get formal, we'll add these reasonable rules, right? Now, so you see how that gives me this line if I have those other two things. Everybody buy this? Anybody have questions about it? Right? What I'm doing is I have this thing that I need, and I translate it into two things that I need. Right? If I can get both of these, then I'm done. Right? So now my goal is to get this thing that I need and this thing that I need. All right, so we can do them in an order. I prefer, right? Well, let's do it this one. Here we need this and we have that, right? Can I get from this line to this line, right? This line says that every f of x is true, right? Everything of the form f of x for any x, this is true, right? That's what we got, right? So we can get from this line to this line. And how are we doing it? We're taking this x, well, I don't think that's even true. Let's see. That might be a false line here. What are we doing? We're taking this x and replacing it not with f, we're replacing it with this x, right? Everybody see that? Forget, that's another bug. Take this, here we're taking, this is true for an arbitrary x. If it's true for an arbitrary x, it's true for x sub exists. Right? Everybody good? All right, now this one. We have this line, and we want to prove this line. Right? So, what do? Well, oops, let's move forward. We know it's true, something is true for every v, right? Now, so I could remove the y, I can remove the Forall v and put anything in there, right? If it's true for all y, sorry, if it's true for all v, it's true for anything, right? And what do I want to give her? I kind of want to give her this y here, right? Just sort of text manipulation. This is what I want to prove. And this has a v over here. And what do I want over there? I want a y over there, right? So if it's true for every y, well, it's true when I plug in this y. And where did this y come from? Well, it was sort of the y that my oracle gave me, right? Not my oracle, my adversary gave me, right? But how am I doing it now? I'm doing it by, we're supposed to be doing it purely syntax, right? So purely symbols, right? So here's the symbol y here. This is the line I want. I need a y here. So I'm going to remove the Forall and I'm going to replace it with a y. Right? Does that make sense? Am I losing you? It's getting hard, right? How are people doing? Right? We only got one more line here. Right now, this is saying there exists an object that's true. Right? If there exists an object that's true, what am I formally allowed to do? I'm allowed to replace it with there exists something, right? But does the u depend on the y? Right? Here, y is a free variable. And so I'm saying that there exists a u, but that u depends on the y, right? So what do? I can go from this line to this line, right? I'm saying, well, there exists an object. Well, we haven't talked about this x yet. Where did this x come from? Right? I just said I needed some x. But where did this x come from? It came from, well, there exists something, so let's call it x exists. Why did I call it x exists? Well, because that was my guess to call it, And then, but I made it x is a function of y. Right? That's why we have x as a function of y all through here. Right? People following this? And that's our proof, right? And then we can get rid of this, and we can say that was a great proof, right? Everybody kind of, it's hard, right? Now, why do I not like this proof, right? Going forwards, the proof, going backwards, I could see how it was the same, right? Going forwards, it's like, well, at this point, we took this y. Well, where does the y come from? We know it starts at the adversary and works backwards, right? But if I was proving it line by line, how do I know to replace this for all v with a y, right? And then similarly, right, this exists u. Well, actually, if I was going forward, I'd probably change this exists u into u exists. And that would be actually fine too. It would be u exists all the way through, right? But yeah, I think these are hard to come up with.